Now we're on page 8 of the Chapter 10 AP Chemistry packet, and we just learned in the last video how we derived the Clausius-Clapeyron equation from the graph of ln Vp versus 1 over t, and now we're going to use that equation to solve for a missing variable. So I'm going to use the equation up here, ln Vp2 over Vp1 equals negative HVAP over R times 1 over T2 minus 1 over T1. Now, just a word of caution about the book, because if you look at the book, you're going to notice theirs looks different. What they did is they inversed these two and got rid of this negative sign, because the laws of logs say that if you multiply this by -1, it's like inversing this. Or, instead of doing that, you could get rid of the negative sign and switch these two around, so it's 1 over T1 minus 1 over T2. Personally, I find that very confusing, because this, to me, follows the point slope form a lot nicer, because you've got your 2, 1, 2, 1, and it was a negative slope, so therefore there's a negative sign, because HVAP itself is always a positive number. So you'd have to take the negative of a positive, and this is always positive, to get a negative slope. So to me, I like this better. If you like the book way, that's fine, but I'm going to show it with this method. All right, so now, of course, they're going to give us 4 out of 5 variables. So here are the variables one more time. Vp2 and Vp1 are variables. HVAP is a variable. T2 and T1 are variables. There are 5 of them. You're going to get 4 of them. So let's see what we got here. We got a torr and a temperature. So this is a vapor pressure and a temperature. And then since it says normal boiling point, we know that the vapor pressure is going to be 760 torr because it said normal. Let's fix that. Okay, so that was a piece of information that wasn't obvious unless you read the problem. And we're looking for the heat of vaporization. So we're looking for HVAP, and we know Vp2 in 1 and T2 in 1. Now we just have to put them in the right units. So we're going to write ln of Vp2. Now it doesn't matter what you pick as 1 or 2 as long as you're consistent. So I'll pick this as number 2, and I'll pick this as number 1. So Vp2 is going to be 760. Vp1 is going to be 100 torr. They're both the same unit. We don't know the HVAP, so that's what we're looking for. The R is 8.31. Again, that's in joules per mole Kelvin, just to remind you. And then the 1 over T2 and 1 over T1 have to be in Kelvin. So the T2, normal boiling point of 78 degrees Celsius. So you're going to have to take 78 plus 273. 78 plus 273. So this is going to be your 78 plus 273. And then the other temperature was 30 degrees. So it's going to be 30 plus 273. So now what you need to do is you need to do the math for this. Just becomes a big algebra mess. So my recommendation is to get this mess on the left side right here, then divide by this mess on the right. What you could do with this is, I'll write down the temperatures here so you can see them. This is a, this is a 351. This is a 351. And this is a 303. So on your calculator, I would do 351 inverse, that's the x to the minus 1 button, minus 303 inverse, get that answer. And then you'd have to do ln, so do 760 over 100, which is obviously 7.60. So take the ln of 7.60 divided by this answer right here, multiply by 8.31, and then take the negative of it, and you'll find the answer. So you should get an HVAP to be 37343 joules per mole. There's no Kelvin there because these Kelvins right here, Kelvin, Kelvin, are going to cancel out this Kelvin. So you're just going to have joules per mole as your answer. And there's no unit here because they divide out. So there's your answer. If you want to change it to kilojoules, what you could do is write 37.3 kilojoules per mole. So there's your answer to the first part. That is the heat of vaporization of ethanol. Now we're going to look for the vapor pressure of water at 50 degrees. So again, we're going to use our regular setup here of ln Vp2 over Vp1 equals negative H vape over R times 1 over T2 minus 1 over T1. Again, look for what they tell you in the problem. They're giving you one temperature here, and they're asking for the vapor pressure, so that's going to be your unknown. And they're giving you the heat of vaporization of water, but it seems like they're not giving you enough information. But the fact that they told you water, a big trick is that you have to remember the normal boiling point of water. So you know that water boils at 100 degrees Celsius. So at 100 degrees Celsius, it has a vapor pressure of 760 millimeters of mercury. So that's going to be one of your data points. So I'll call that data point 1, and this is going to be data point 2. Another big trick is look at the units they gave you here, joules per gram. But remember, the heat of vaporization has to be in joules per mole. So we're going to do a little side calculation over here. And we're going to do it, I'll do it on the bottom, 2260. So 2260 joules per gram. But we're going to get it into moles, so I got to get rid of grams and go to moles. We're talking about water, so that weighs 18 grams per mole. So when you do that math, you're going to get 40,680. 40,680 joules per mole. So this is the H vape of water. So we're going to put that over here. That's going to be, you have to put a negative because there's a negative over there. So 40,680 divided by R is 8.31. Again, look at your units, joules per mole Kelvin. You have to do your T2 and T1 in the denominators. So again, I picked this as my T2.